Hello, this is Mr. Arthur, and this is our second lesson of energy and ecosystems, and this time we're going to look at pyramids. So, what we're going to look at is how a food chain can be represented as a pyramid. Now, this could be as a pyramid of numbers or as a pyramid of energy. Once you know the difference between these two pyramids, you should be able to match a food chain to the specific pyramid which represents it. We also want to understand why pyramids of numbers can be irregular, but pyramids of energy cannot. So why pyramids? We're using pyramids as a graphical representation of the data. So if we look at our food chain here, we have a producer, we have a primary consumer, and we have a secondary consumer. So that's our food chain. We can represent this as a pyramid. The population of the producers is the largest. The producers always go at the bottom of the pyramid because the producers are the first level of the food chain. Next comes the secondary consumers. This is the second level in the food chain and the second level in the pyramid. The population, in this case of the African hares, is smaller than the grass that they feed on, and at the top is the secondary consumer. Again, the population is smaller. A population of predators will always be smaller than the population of the prey that they feed upon. And that's simple because if you ever get more predators than prey, there's not enough food and many of the predators will die. Okay, so this is a pyramid of numbers. So let's look at the data itself. So here we have our three species, the grass, the African hare and the cheetah, and I've given you some population sizes there. Now, how can we represent this data? Well, we said that the producer always goes at the bottom of the pyramid. The African hare feeds on the grass to get its energy, so the African hare will be the second level of the pyramid. And then the cheetah is getting its energy from consuming the African hares. Okay, so first of all we have the levels in the correct order. Now we need to represent this as each bar is going to represent the size of the population. So the grass is by far the largest, so it will be the widest. We then look at the African hare now, that's going to decrease to 23,000, so we need to make that narrower. And then there's only a smaller population of cheetahs feeding off these hares, so the cheetahs will be the smallest one. So you can see that each bar represents proportionally the size of the population of that species. And when you put the bars on top of each other, it begins to look like that pyramid. And that's why we call that a pyramid of numbers, because the numbers refer to the number of each organism of that species at that level of the food chain, okay? So you can think about it as the population. And when you represent that as bars, we get the pyramid shape. So this is a regular pyramid of numbers. Regular because it's the standard pyramid shape. Now we're going to look at irregular pyramid of numbers. So, in this case, we have one tree. On that one tree, there's a large population of insects. And then the birds get their energy by feeding on the insects, so there'll be less birds than insects. Okay? Now, if we look at this in terms of bars, we have the levels in the correct order. We have producers, we have primary consumers, and then we have secondary consumers. But this time, we change the bars to represent the population size. It's going to be very narrow at the bottom because there's only one tree. Then there's a large population of primary consumers. And then there's a smaller population of secondary consumers feeding upon these. So this is what we call an irregular pyramid of numbers. Remember from lesson 1, only a small quantity of energy used for growth is available at the next level of the food chain. Okay, so the energy is used for growth. When something grows, it's going to gain what we call biomass. Now you probably know mass from physics. Mass is how much of you there is. Okay, often confused with weight. So weight's actually a force. Mass, if I'm saying like I'm 12 stones, that's my mass. Okay, the biomass then is the mass of living material. If you look at this tree, the energy from the producer, from photosynthesis, is passed on to the insect. I know that because the arrow in a food chain shows the flow of energy. And then that energy is used by the primary consumer here, the insect. It's going to use some to move, it's going to use some is heat energy, and some of the material is going to be undigested. It's only getting a small proportion of the energy it gets from the tree in which to grow biomass. The energy that is used to grow, though, is available to the bird, which eats the insect. Okay, You can see on the bottom there we've got 100 joules, 10 joules and 1 joules, because only 10%, only a small quantity is being passed on to each level. Okay, this is the basic understanding from lesson 1 that you need to know before we continue with this lesson. So energy decreases as you move up the food levels. However, the pyramid of numbers doesn't take biomass into account. Okay, it doesn't matter if it's a small organism or a large organism. A pyramid of numbers is just the number of organisms. So there is only one tree. But because one tree can be very large and it has a lot of biomass, even if only getting 10% of its energy passed on, it can support a larger population getting its energy from that. So in this case, it will be one small population supporting a larger population. Okay, then we're going to have the birds. Now the birds are getting their energy from the flies or the insects, but remember, they're only getting a small proportion of the energy. The birds are in competition, and if the top bird outcompetes the bottom bird, because it's saying it needs 4 insects to stay alive to get enough energy, they can't both get the 4 insects, so one's going to die out. So if you think of this as back to population size, population of 1 is the tree, then we've got a population of 4, then a population of 1. And that is why pyramid of numbers can be irregular. So there's the two next to one another. The regular on the left is a large population, small population, small population. Then we've got one small population, but it's a large organism supporting a larger population, and then a small population again on top. Energy is always flowing up the pyramid from the bottom to the top, but in terms of numbers, the numbers of number of organisms of each species supported can differ. Okay, so energy always decreases as we move up levels in a food chain. So rather than looking at pyramids of numbers, we can start to look at the pyramids of energy. The energy is that's available in the biomass. Remember, it's the energy that's used to grow by the organism that's available to whatever consumes it. So the plant's got 100,000 joules there for growth. When the rabbit eats the plant, it's going to get a small quantity of that, so it'll get 10,000 joules. It's going to use for growth. Some of this, it's going to use some of this for growth. Some of it's going to lose its heat through movement, through undigested materials. So when the cheetah eats the rabbit, it's only getting 1,000 joules. That's 1,000 joules that were available in the growth of biomass in the rabbit. So if we align this like a pyramid by size, the producer's always at the bottom, so it's got the most energy. Primary consumer's second level, it's got less energy. The secondary consumer's got even less energy. This is why we say that pyramids of energy are always regular, because energy has to decrease as you move up the levels of the food chain. Okay, so a pyramid of energy will always be regular. So there's the two of them next to each other. These are both regular. The pyramid of numbers, pyramid of energy. Pyramid of numbers shows the number of each organism at each level of the food chain. Okay, it doesn't take biomass into account. However, the pyramid of energy shows the energy available in the biomass at each level. Here on the left, we've got an irregular pyramid of numbers, and that's because there's only one tree supporting the larger populations above. Okay, so it's irregular, but the pyramid of energy is always regular. Okay, true or false? These are all examples of pyramids of energy. Is that true or false? That's false, because the first one on the left and the first one on the right are both irregular, and pyramids of energy will always be regular. Okay, so this one's false. Can you match the labels to the picture? So one's a regular pyramid of numbers, one's an inverted pyramid of numbers, and one is an irregular pyramid of numbers. So pause the video, have a shot at doing this, and then press play when you want the answer. Okay, over here we have got the regular pyramid of numbers in the middle, because the largest population is in the bottom and the population size is getting smaller each time. This is an irregular pyramid of numbers because it's one tree supporting a larger population of insects and then a small population of birds. And the one on the far right then is inverted. It looks normal at first if you cover the top. You've got a larger population of plants or producers. It's supporting a small population of deer, but there's very small organisms called ticks which are living off the deer. Now, one deer could have thousands of ticks on it. Therefore, it's inverted because the pyramid gets larger again at the top. Okay, so that is our learning intentions. Pause now and make sure and see if you can do all of these yet, or if there's some you need to go back and rewatch part of the video because you're still not sure about. Continue on with the video when you're ready to try questions. Okay, I want you to pause now, try these 6, and then only press play when you're ready to check your answers against mine. So pause now. Okay, ready for the answers? Here you go. So again, you can pause now and check your answers against these. Okay, we're going to finish by looking at a past paper question. We're just going to look at this one here. So it says a food chain can be shown as a pyramid of numbers. Identify which pyramid would be used to represent the food chain, which is at the top here. Okay, so we're looking at pyramid of numbers. As a reminder, that's talking about the population. How many of each species are there? So our food chain at the top, we've got a gooseberry bush. So that sounds like singular. We've got caterpillars, we don't know how many. Blue tits is plural, don't know how many. And hawks is plural. Okay, so this is going to be a little bit tricky. First of all, it's one bush, so I'm going to rule out C. Both of these have a narrow bar at the bottom, which is the way you'd represent a small population such as 1. We don't actually know the population of the caterpillars, blue tits and hawks, so how are we meant to answer this? Well, we can't tell the size of the bars, but the shape should give it away. On A, it's getting smaller each time, and B, it's getting larger each time. Now remember the rule, as energy is passed up from level to level, there's less and less energy available. Because there's less energy available, there can't be a large population at the top here, okay? The hawks aren't small organisms living on the blue tit. The hawks are consuming the blue tit to get their energy. If there's more hawks than blue tits, there's not enough food for all the hawks and the hawks will die. So therefore, B can't be true, and that leaves us A is the correct answer. There can be a large population of caterpillars living in a bush. The blue tits will compete for these caterpillars, so there'll be a smaller population of blue tits, and the hawks will compete to consume the blue tits, making them even a smaller population.